hope that you can all hear me clearly, and I hope that you are ready to go. So, pen, piece of paper, and ready to go. Okay. Yesterday, we talked about how to turn fractions into decimals. I want to just recap over that lesson a little bit because when you sent me some of your answers, some of them weren't quite correct. So I just want to go over that again for a couple of minutes. And then we're going to do something else. I'm going to show you how to convert decimals into percentages. Okay. And I'm going to show you two ways. So at the end of this lesson today, you'll have two ways that you'll be able to convert decimals into percentages. So everyone who's online now, I'm just going to say hello to. So the people I can see, so we've got Tegan, Chedza, Abdullah, Sahil, Lydia, Elsie, Ella, Khadija, Fatima. If there's anybody I missed, quickly put your name. Amani that is there. Isa, Dowd, and I think Yassine. Morning, Yassine. Mariam. Momina. I think I've said Elsa. Morning, Parisa. So there's quite a lot of people on again. We're going to get going. Right, so yesterday we talked about how to convert fractions into decimals. So I'm just going to go over that again, okay? But today's lesson is going to be about converting decimals to percentages. So they're all linked to each other, okay? Morning, Kaimane. Morning, Arvin. So yesterday we talked about how you convert fractions to decimals. So we're just going to look at some examples so that we can work through it. So the first thing is, what does that bar mean? That bar is super important. What does that bar that separates our fractions mean? Now we've done this quite a few times, so we need to be able to do this really quickly. Morning, Salad. Morning, Charlie. So what does that? It means divide. Well done, Preset. Biggie shout out first. Morning, Tafia. It means divide. So that bar in the middle just means divide. So if we was to rewrite that calculation as a calculation, it would mean 4 divided by 5. Okay? 4 divided by 5. Or 4 out of 5. 4 divided by 5. To be able to find out what the decimal is, we draw our bus stop and we put our 4 on the inside because that's how much we've got, and the 5 on the outside, that's how much we're going to divide it by. Okay? What's the first digits going to be in our on our quotient on the line above? What's that always going to be? If the number on the inside is smaller than the number on the outside, what's that always going to be? What's it always going to be? Well done, Parisa Sahil and Khadija and Jagir. Yeah, it's going to be 0 because we can't. If we've got 4 pieces of cake, it's going to be less than 1 piece there getting each of these 5 people, isn't there? Okay, so 4 pieces of cake can't be divided equally into 5, so it's going to be less than 1. So it's going to be 0. Okay, the next point is super important because we have to line up our decimal points. So we put our decimal point after each of the digits, the 0 and the 4, and we have our decimal point. And the rest now is just completing it like we would complete a normal short division question. But after the 4 point, there are infinite zeros. Now you can't see them, but there are infinite zeros. So we're going to put in a few zeros. Doesn't matter if we need them or not, we're going to put in a few zeros. So now we complete it the same. So we see how many times 5 goes into 4. We know it's 0. So we carry the 4 across. And we see how many times 5 now goes into 40. Well, 5 goes into 40 8 times. So 4/5 as a fraction is 0.8 or 0.80. Okay, if we do it to 2 decimal places, it's 0.80. Now, sometimes you might see in a question 2dp, and that means 2 decimal places. That means 2 digits after the decimal point. Okay, and if it was 3dp, it would mean 3 decimal places, which is 3 digits after the decimal point. Okay? But in this case, we've done 1 dp, which is 1 decimal place, which is 1 digit after the decimal point. We're going to have a look at the next one, which is the same sort of scenario. We're going to convert it. We know that the bar in the middle, and we should all know that by now, the bar in the middle means divide. So if we was going to rewrite this, what would we rewrite it as? Show me in the comment section what we would rewrite this fraction as if it was a calculation. Good morning, Alina. What would it be? Well done, Moms. 5 divided by 8. Well done, Yassine. Well done, Zuleika. Morning, Zuleika and Moms. Yep, well done, everybody. So it'd be 5 divided by 8. Now, we put the 5, we draw our lovely little bus stop. Now, you don't need to make it neat, do you? It's not important about it being neat. It's about it being right. So we put our 5 inside the bus stop. That's how much we've got. And 8 is what we're going to divide it by. So we put that on the outside. Okay? Our first digit is always going to be 0. Somebody tell me why in the comment section, why it's going to be 0. Why is it going to be 0? Why is it going to be 0? Ooh, who's going to be first? Who is going to be first? Well done, Yassine, you were first. It is because 8 is larger than 5. So if we have 5 pieces of cake and we divide it by 8, the number is going to be less than 1. So 0. Okay? Then we need to make sure we put our decimal points in. So we line up our decimal points. Okay, well done, everybody. I'm liking the fact that everybody's saying 8 is larger than 5, so it doesn't go into it. Well done. Well done, Khadija and Zuleika and Amani and Elsie. Well done. So we got our decimal points, and now we're going to complete it the same. So we put in some imaginary zeros. We've got some lovely zeros there. And then we complete it how we would usually. So 8 doesn't go into 5, so we carry it over. And we now do 8 into 50. Okay, well, what does 8 into 50 go? How many times does 8 go into 50? Yeah, Charlie, is 48, but how many times is that? How many 8s is 48? Well done, Abdullah. Dowd, think again. Well done, Parisa. Well done, Amani. Yeah, it goes in 6 times. So now I've got 0.6, but it leaves us, it's 48. Charlie said correctly it was 48, which means we're left with 2 left over. And we do see how many times 8 goes into 20. Well, 8 goes into 20 2 times. And it leaves us 4 left over. And 8 goes into 40 5 times. Okay, and leaves us nothing left over. So 5/8 as a decimal is 0.625. Okay. Now I know I've gone through that really quickly, but this is yesterday's lesson, and what I wanted to do was give us a chance to just recap that, because it's really important for you to be able to convert a fraction to a decimal, for us then to be able to convert a decimal to a percentage. Okay, so at the end of this week, I'm going to give you some questions on Friday which are additional, which are going to be converting a fraction to a decimal to a percentage, and that will hopefully build on the knowledge that we've got this week. Okay, but we're going to go on to the main part of the lesson. Who can tell me what it means? Well, I can tell you its percentage means by part of 100, which means that it's out of 100. So an example would be 25% as a fraction is 25 out of 100. Okay? So 25 out of 100. 53% would be 53 out of 100. Okay? So all percentage means it's part of or out of 100. Okay? So part of 100. let's look at some of the numbers that we did before. I'm going to show you method 1 first, okay? And it's a little bit more complicated than method 2, but I want you to get the idea of it. The first thing with all of these methods is you have to draw a place value grid. So while you've got your pen and piece of paper now, draw yourself the quickest place value grid you've ever drawn. Now you'll know, if you've been in any of my math classes, that actually the place value grid and being able to draw one and label it perfectly, quickly, is super important. It doesn't matter if it's a place value grid and you're adding or subtracting, or a place value grid if you're multiplying or dividing. The place value grid gives you the opportunity to put your numbers in the correct place and work with those numbers. Okay? And if you think back to addition and subtraction, we don't at all draw a place value grid generally, but if we do, it's fine, or we label it. But we know that actually with addition and subtraction, what a place value grid does is it allows us to put them in the correct place value. So you know that if it's 1.42 and you've got 1.543, that you can put them in the correct place value using the decimal point as your guide. Okay. Hopefully you should have drawn one by now. So that's our first step. Okay. Now I'm going to look at some of the digits that I used before. So in this case, I'm going to look at 0.80, which we knew before as our 4/5 as a fraction. Okay. Now the first method I'm going to teach you is simply to look at the digits after the decimal point. Now it's important when you are putting them into your grid that you put the decimal point in and you put it in at the right place. Okay. So looking at this, all I'm going to do is I'm going to circle now the 2 digits after my decimal point, okay? And I can see that the 2 digits after are 8 and 0, okay? I'm going to then write those 2 digits with a percentage sign. And that is my percentage. Now you're probably thinking, why is it that? So I'm going to tell you why it's that, okay? If you look at the columns above and the names of the columns, we have ones, tenths, and hundredths, okay? So the number 1, if we had 1.00, would be 100%, okay? Would be 100%. But because we don't have a 1 in the ones column, which is 0, and we have 8 tenths and 0 hundredths, we have 80 hundredths, okay? Well, 80 hundredths, if we think back to the fraction before when I said 25 100ths were 25%, 80 hundredths is equal to 80 out of 100, okay? So the reason it's 80 and not 8 is because we have our 0 in the hundredths column, which makes it 80 hundredths, okay? 80%. But what about if our fraction is the one before? So we're going to plot the number again. We've drawn our place value grid. We plot our number, okay? And now we've got 3 digits after the decimal point. Well, actually, this is a bit more challenging with this method, but not super challenging because we're going to follow the same steps. So I've put in my decimal and I've put in my digits. I'm going to look at the numbers after my decimal point. So in this case, I've got 625. Okay, 625. I'm going to write those digits underneath 625 with a percentage sign. But hold on, it's not 625% because it's not over 1. So if there are 3 digits in the percentage, after the first 2 digits, you're going to place a decimal point. So we've got 625, but we look at the first 2 digits, 62, and after that 62, we put a decimal point. So it becomes 62.5. Okay. Now the reason for this, there is a reason for this. So let's just click on that. Yes, there is a reason for this. And the reason for that is because when we look at the number here, this number here, okay, we can see it's 625. Well, if we was to write that as a fraction, it would be 625 over 1,000. Okay. Well, we would need to get that 1,000 to 100. So if we divided that by 10, we would have 625 divided by 10, which would be 62.5. Okay. We'll look at one more. So this time we've got a number which has got a 0 placeholder in the tenths column. Following the same steps, we write the number in the correct place value. Okay. And we write our digits. So we circle them and we write our 3 digits underneath. So we've got 0, 3, 2. Well, first of all, that doesn't look right, does it? Okay. It doesn't look right at all. 0.32%. But following the same steps as before, I look at the first 2 digits, which is 0 and 3, because I've got 3 digits, and I put a decimal point after the first 2 digits. So my decimal point goes there. Now, obviously, 0.3.2 doesn't make sense. So what we can do in this instance is we can get rid of our 0. We don't need a 0 at the front, so we can get rid of our 0. And it becomes 3.2%. Okay. What I'd like you to do now, I'm going to give you a 2 decimals. 2 decimals. I want you to write them down, so I'll give you a bit of time. So here's the first one. I want to know what 0.14 is as a percentage. And I also want to know what 0.054 is as a percentage. So I'm going to put that in the comment section for you to... So I want to know what 0.14 and 0.054. I want to know what they both are as a percentage. Well done, Momina, Yassine, Abdullah and Ella. Well done, Yassine. Again for the second one. Unhygienic banana, can you check the second one, please? Well done, Arvin. Well done, Charlie. Well done, whoever NOSCOP3S only is. Well done, Dowd. Well done, Zuleika. Well done, Abdullah. Well done, Dowd again. Well done, Issa. Okay, so you can see that I think that is a little bit more complicated than the next one I'm going to show you. Okay. Well done, Kaimane. Make sure you put the percentage sign though. So we're going to move on. To the next one. Okay, so method number 2. So method number 2, I think, is a little easier, but I wanted to get you to understand how it works first. So the steps are very similar. The first thing you're going to do right now is what are you going to do first? What you're going to do first? No. What's the first thing you're going to do? You have a pen and a piece of paper. What's the first thing you're going to do? If you be asked how to convert anything, what's the first thing you can do? Khadija, well done. You're going to draw a place value grid. So I've drawn mine here, and it's all neat and lovely. You can draw yours however you want to, with whatever you want to. You can draw it with a potato if you want to. It doesn't matter. As long as it makes a mark and you can label it correctly. So the first thing you can do is draw a place value grid. The second thing you can do is you're going to plot your decimal. Okay, so I'm plotting the decimal of 0.15. So far it's exactly the same as the previous method. The only difference now is we're going to use our understanding of multiplying by 100 to help us. Okay, multiplying by 100 to help us. If I am multiplying by 100, what way am I going to move these digits on my place value grid? What way am I going to move them? If I'm making the number larger, how am I going to move these? How am I going to do that? Which way am I going to move them? Left. I'm going to move them left, yeah, because if we are looking at the place value grid and we're going larger, everything is going to go to our left, which when you look at the screen now, you're looking at right, so I'm going to go to the left. And if I'm going to multiply by 100, how many places am I going to go to the left? And why? Why am I going to go the amount of places to the left? Well done, Abdullah. Well done, Jojo. Well done, Yassine. Well done, Charlie. So it's 2. So, but why is it 2? Tell me why it's 2. That's really important to know why it's 2. Well done, Dowd. It is 2. But why? Why is it 2 places? If I'm multiplying by 100, why is it 2 places? Okay, Parisa. So part of it is that it's 2 zeros. So that's our little cheat. It is because it's 2 zeros. So yeah, there are 2 zeros in 100. Okay. But actually, the reason is this, is we are multiplying it by 10, and then we're multiplying it by 10 again. So each of our columns in our place value grid are 10 times more than the column next to it when we're going left, okay? So ones, tens are 10 times more, tens, hundreds are 10 times more, hundreds, thousands are 10 times more. So the reason we're doing it twice is because we are multiplying it by 10 and multiplying it by 10 again. So we're going to move all of our digits 2 columns to the left. So let's do that. Okay. And then we're going to write those digits underneath. So we've got 0, 1, 5. And all we're going to do now is get rid of the 0 at the front because we don't need that. So we've got our 15%. Okay. So this is a little bit easier than the last one because all we're going to do is we are going to multiply by 100. So whatever digits are in our place value grid, all we're going to do is move all of those digits 2 places to the left. But this is why it's important for you to know it to the left for a start. We need to make sure we're going to go to the left, but also for us to know that we can draw our place value grid correctly. Sorry. So moving on to the next one, we'll give it another go. We put our number in, and we're going to look at our digits, and we're going to multiply by 100 because we're multiplying by 10, and then we're multiplying by 10 again. So we're going to move 2 places to the left. Let's do that. So all of our digits 2 places to the left. And then we simply write those digits underneath. So we have our 063.1. We include the decimal point. And then we don't need the 0 at the front, or any zeros at the front, actually. It doesn't matter. It could be 0 point whatever. We are going to get rid of those, which leaves us the percentage of 63.1. Okay? This, if you think this is easier than the first method, put a thumbs up. Who is Mushtaba? Well done, Khadija. Well done, Momina, Zaleika, and Jojo. Okay, so I think this is much, much easier because you're multiplying by 100. So what I want you to do then is I want you to tell me, using this method, what this would be as a percentage. So draw your place value grid, plot your number correctly, and then move it 2 places to the left. Take another look, Sophia. Only 2 places. Well done, Khadija. Well done, Parisa. Well done, Saba. Well done, NOS. Only 2.5. Well done, Jojo. Have a look again. Amani, brilliant. Sahil, brilliant. Chedza, have another look. Khadij, great. Dowd, brilliant. Abdullah, have another look. Zuleika, Elsie, Jojo. Well done, Abdullah. Well done, Dowd. Well done, unhygienic banana again. Okay, so you can see that if we move everything 2 places to the left, I think there was a little bit of an issue there with people guessing, if I'm honest. The reason the place value grid is there is so that you can count the amount of spaces that you do it. When you are super confident and you think, actually, I can get this, this isn't difficult at all, and some of you are, I'm sure, are absolutely there, then you don't need to draw the place value grid. But if you're guessing at 25%, because you can see a 2 and a 5, that means you've moved it 3 places to the left. Okay, so make sure that you draw that place value grid to ensure that you're not making a simple mistake, because that would be a pretty simple mistake. And even in a test, or not even in a test, if you were just trying to work something out at home, you wouldn't have that opportunity, would you, to rectify it? It'd be a mistake, and you would lose that mark in the test, or you would get the wrong answer at home. Okay, so we're going to move everything 2 places to the left. So our 0, another 0, our 2, and our 5. We write underneath with a percentage sign, but we don't need our 2 zeros. Okay. Right, today's been quite a meaty lesson. So we encourage you to come back and have another look at this if you're not quite sure, okay? Because we're going to add to this tomorrow with more decimals and fractions to percentages, to ensure that by the end of this week you are much, much better at being able to convert a fraction to a decimal to a percentage. Now, I encourage you really to go and have a look at the ones that you should know just instantly. For instance, 25% equals 25 over 100, or 1/4, and it also equals the decimal of 0.25. Okay, so you really need to know, without even thinking, what 25% is as a fraction and a decimal, 50% is as a fraction and a decimal, and 75% as a fraction and a decimal. Okay, so those things you need to go and have a look at yourself. This is a bit more complicated, but there is no decimal that you cannot convert now into a percentage, as long as you follow the rules of either moving it 2 places to the left, or you follow the rule of whatever digits are after the decimal, you write as out, and then you put a decimal point 2 digits after that. Okay, I'm going to leave this on so you can write them down, but for a second, if you don't manage to do it, write them down now, that's fine. The video will be online straight away. I will come back in a couple of minutes, and I will then move to the next slide, which is your challenge questions. All of these you can send online to me, and I will post the answers next week on Monday so that you can check your own answers. I do have a look at the answers every day, but obviously there's quite a lot of children doing it, and it's difficult to get through all of the answers. A brilliant effort today, and lots of you having a chat at the same time. And whoever said, "Oh, do you know what? We should do lessons like this at school?" Absolutely not, because if you were talking at school, we wouldn't be getting through much. But because I can't hear you talking, and it's all typing in, that's a different thing altogether, isn't it? Okay, so thank you again for taking part. I will see you again in a couple of minutes just to say goodbye and give you the last thing that you're going to do. And I'm going to leave the chat running for 5 minutes after I've logged off myself. Okay, so I shall see you in a minute. Okay, so you should have had a chance to write all of that down now. It's nice to see you, Noreen. Your alarm didn't alert. Wow, unbelievable. Some people. Okay, I'm going to move on to the next little bit, and I'm going to leave that running for quite some time for you, and you can carry on chatting. Once again, thank you for coming to the live lessons. Like it if you like it. Don't like it if you don't like it. I understand you have a free choice not to come to these lessons and everything else. But thank you all for turning up and taking part. And I'm glad you get a chance to actually have a chat with each other and a chance to actually have a laugh together. That's really important in all of this to make sure that you continue to do that where you possibly can. Okay. So have a great day, and I hope that you are doing something fun today, like jumping on the spot for the next 6 hours so you're tired and you go to bed at 6 o'clock and your mums are all elated because they can have 10 minutes to themselves. If not, have a brilliant day. Here are the last questions. I'm going to leave these on and say goodbye. Have a brilliant time. I will leave chat running until 1:45. So have a great day, everybody, and thank you once again. Take care of yourselves.